All right. Hey, and welcome to Red Team, the best team. And I am here with Osku, that is OHT2 OSQ on Twitter. He will be taking your questions via Twitter DM. He is the chief security engineer at Sonoma Media in Finland, founder of Helsik, which I would imagine would be for short for Helsinki Security, and builder of Home Labs, who spends most of his time hacking and building stuff. Welcome, Osku, to Isolation Con.
Thank you. I'm excited to be the first speaker because then the unbearable stress of doing a presentation online is sooner over, and I can have a cold one and follow the next talks. My name is Osku. I work with Sanoma Media Finland, which is a large Finnish company running the oldest newspaper, I think, in Finland. And just a quick update on the situation with Corona in Finland. I'm not the Corona authority, but anyway, we have been working remotely for about 5 weeks. Situation isn't really too bad at the moment. People are distancing themselves fairly well, and the weather's been getting warmer and nicer, and today it was a very sunny day, or actually still is. I went to my favorite archery field outside the town with like 15 kilometers ride on my e-bike. So when I'm not hacking things, I'm, riding my bike around and shooting things with a long bow. And so about me. So I used to be a software developer for about 20 years in various roles in different companies. And I very recently switched careers into doing security. So currently I'm chief security engineer with Sanoma Media Finland. So it's like 2 years ago, I decided I want to do something else and develop software. So I started studying basically offensive techniques first. I did some Hack the Box and did my OCP course a bit over a year ago. And now work as a chief security engineer with a number of fun tasks, including like making sure application security actually happens and helping the real security team around in the company. And I'm trying to maintain a fairly active presence in the local communities. I co-founded Helsec, which is a local infosec bunch of people in Helsinki region, and I'm a member of a couple other citizen groups, as we call them. And I'm developer of the automated subnet scanner, abbreviated ASCAN. And well, that's it. You can follow me on Twitter if you want. And I'm also these days present at the Many Hats Club Discord. So if you have further questions about my talk or about anything else, you can find me there. So the agenda for this presentation is that I'll briefly describe the basic setup of my home lab. And then I'm going to just present a couple cool things I built with the lab. And the reason I'm doing this presentation at all is that because people are spending a lot of time in isolation and that they hopefully have time and energy to learn something new maybe or pick up some new skills. I hope this presentation will be an inspiration of what are some of those skills that could be useful. And I tried to add to a couple slides some keywords in them, which means that if you take those keywords and Google them or DuckDuckGo them or whatever, you will find more information. So my home lab build is basically just that I've been Googling stuff and following instructions and ended up with something that works for some things I want to do. And I'm not exactly a home lab authority, but I'm just define home lab as the collection of things at your home that you can do stuff with. And basically there's a network that supports computers or servers doing their things in those networks. And what do you need a home lab for? You need it to, well, study things and practice setting up things you wouldn't be able to do without an environment. So you could build your own Active Directory environment or practice creating your own public infrastructure or just try different OSs on virtual machines or run some stuff you download from Vulnhub. So it's basically just an aid in doing self-study. And you don't actually need too much hardware to build your own home lab. Basically, you can get a minimal setup with only like one extra PC. A laptop will do just fine. And if you have more computers, you need a network so that they can talk to each other. And even your modem is a switch already. So just get one extra or dedicate one extra laptop and you can start building a home lab. And for more ambitious setups, you want to have something more than just like one laptop. If you have old desktops lying around, they are really good because they're fairly easy to upgrade from memory and disk, or easier than a laptop. And I'm running a separate router on a dedicated hardware PC. And any PC is good for that. Any potato can do. Like the router doesn't need that much power, computing power. And as I'm mostly talking about how I built my environment, so I just like mentally set these requirements to my own environment. So I still want to do like normal things with computers, like do gaming and browse the internet and do some remote work. And then I want to have a lot of different networks so I can do different things in different networks. So one of the networks run a full Active Directory environment with a couple Windows servers, virtual of course, and Windows workstations, and some other networks for IoT devices, and one more that I can run vulnerable computers in so that I can firewall that network from the other ones. And then for some lightweight OSINT stuff that I do, I set up a network for that routes absolutely all traffic through a VPN so that I can, for example, connect a cheap Android phone bought with cash with a prepaid through that VPN so that it never appears to come from my home network. And with the virtual server platforms, I want to be able to easily create and run lots of virtual machines. And as an added bonus, one of the boxes running my virtual environment is a really small computer that fits in a bag fairly easily. And when I need my home lab elsewhere than at home, I can just take that one with me to go. Then a few words about the home lab network. This is the graphical representation of my home lab network. I made the picture myself, which explains why it's so ugly. Basically, this just shows what I just told. So I'm actually not going to go into this picture because I can't point fingers to that image. So what does a router do? So your homelands or the networks in your home lab, they have private IP addresses in them, and the router takes care of routing traffic from those private networks to the public internet and back. And you need a router software to run on a PC to do that. And I suggest you just go and Google tutorials on how to set up your own routers. But the one thing is that I want to run different networks in my home lab, but only have like a small amount of network cables and switches. So how do I go about creating multiple networks with one single shared set of hardware? The answer to that question is using VLANs. And VLAN is an extension to the Ethernet layer. And here's a short summary of how the TCP IP stack looks like. So on the very low level, we have electricity or light or radiation running on cables or fibers or whatever. And on the high level, we have applications and actually humans using those applications. And VLAN happens on the almost bottommost layer in the TCP IP stack. So it kind of abstracts the Ethernet layer so that they can be more kind of virtual networks running on the same cables and switches. And so the Ethernet frame is just a array of bytes that contains some metadata about where those bytes are going to and from. And the VLAN is just an extension to that. So that VLAN Ethernet frame has a number that tells which virtual LAN the frame belongs to. And here are just some screenshots of my cheap Ethernet switch that supports VLANs. So there's a GUI that I can create those virtual LANs with. And I can define different parts and ports on those switches to allow or disallow traffic to certain VLANs. And as a router, I'm using software called pfSense. It's an operating system that's built on top of FreeBSD or forked from FreeBSD, whatever. But basically, it's just an OS like any other, like Linux is. So you get a USB stick, or you can write the installer to a USB stick and stick it to a PC and install. And a short while later, you have a router. And you can also configure those VLANs in pfSense and define firewalls between those different VLANs. But if you only are interested in creating virtual networks for your virtual machines, and you only have one server running your virtual machines, you don't actually need a switch that supports the VLANs. Then to run the virtual servers, there are multiple choices. So you can just install VirtualBox on your main computer, laptop, whatever. So I guess most people already have experience in those. So it's a piece of software that runs on your desktop or laptop, and you can create virtual machines, and run multiple, like many of those on a single computer. But it's not usually feasible to create any more complex environments using VirtualBox because, for one, you need a fairly powerful machines to run multiple virtual machines on, and it doesn't scale well. For example, once I was doing a workshop teaching people some very basic penetration skills, and I had the great idea of running a couple of those target machines on my laptop, and then I run a router on the laptop, and I bridged those virtual machines to a wireless access point. And it wouldn't just work because the VirtualBox kernel drivers couldn't handle a couple tens of people trying to own 4 virtual machines running on a simple laptop. So VirtualBox is great to get started with, like how virtual machines work in general, but you can't really build complex environments with those. And another alternative is a VMware ESXi. I only tested it just a little bit, but there are some people who use it more, and it seems to be okay. And if you want to use virtual machines and actually use like remote desktop sort of things with them, then VMware seems to be okay. But as it's proprietary software, you can't really do all the cool stuff that the full paid version would support. So you can't create clusters of VMware servers easily. And I didn't figure out if it's easy to like use it in any scripted and automated manner. So I've ended up using software called Proxmox, and it's an open source product based on Debian, and I like it a lot because it's very easy to write scripts that deal with virtual machines. So like create them or destroy them, or set up like different properties on those virtual machines. So it has a web GUI, but for some things, it's easier to write scripts to do things. And maybe the only con or downside of Proxmox is that the virtual console feature isn't that great. So it's a browser-based thing. It's like good enough for setting things up, but if you want to use remote desktops with virtual machine guests running on Proxmox, then you need to just set up a native remote desktop connection. Anyway, Proxmox supports pretty much the same things as you have available in VirtualBox, but it's just running on its own piece of hardware, and you have a web GUI to access it. And one thing you should totally research if using Proxmox is a thing called CloudInit. So it's a piece of software that does kind of post-installation configuration on virtual machines, and it supports Linuxes and maybe some other Unix-like operating systems, not Windows anyway. So the point is that you can create a kind of template virtual machine that has, well, just the basic stuff of an operating system, and then you can turn that thing into something called template on the Proxmox. And when you want to create actual virtual machines to do stuff, you do the customization of the host through a CloudInit config. So things that go into a CloudInit config are like, for example, host name or the SSH keys you want to access the machine at, or IP configuration. And CloudInit also supports some automation and orchestration things like Puppet and Ansible and so on. And that's really useful because it takes quite a while to install an OS from scratch on a virtual machine. But with CloudInit, creating a virtual machine is just like a matter of a few seconds or half a minute or so. And I made myself templates for Kali and Debian and Ubuntu because those usually cover most of my use cases. And to run all of this, so this is my hardware built from my home lab. So any older PCs are completely fine for running virtual machines. And I'm running a couple Lenovo S30s running Proxmox, and it seems to be a fairly good combination of like computing power with a low price point. So, well, you can Google any stores that sell refurbished hardware, but I think the key point with the Lenovo is that it's running a Xeon processor, and they are fairly okay for running virtual machines because they come with a lot more cache than desktop processors. And then I have a couple basically just like dumpster finds, just really old and low-end PCs. And I have maybe 5 or 6 of those in total running a couple Proxmox clusters. I'm showing a really short demo of how to use Proxmox. So I guess my other desktops are showing. So actually, I'm only demoing the CloudInit part. So I can SSH to my Proxmox server and list all my boxes. So here, for example, I'm showing a couple templates I prepared. And so I have like a Debian template, which is the last one, or these ones. So if I want to create a virtual machine based on the Debian image, I'm calling a script I wrote. It's not too long, but I'm typing here the template ID and ID for the new box. So contest. I'm adding 5 gigs of disk to that thing and giving it 4 gigs of memory and 4 cores. And that's all it took to create the virtual machine. By itself, this is not so interesting, but I'm showing this just to show that this is all it takes for me to create one more server running Debian. And you can't really do this as easily with VirtualBox or anything else that you can't easily script. So now the box is basically running apt-get, update, and upgrade, and reboot itself once and then it's ready to do whatever I want it to do. Then just going to talk about some of the projects I've done using my home lab. So one is that I can download machines from WoolHub and run them on Proxmox. So usually you could run those on VirtualBox as well. But when I built my home lab, I specifically spent all the money on the servers. I'm running a cheap laptop only to act as a terminal, so that doesn't really have any computing power. But it's possible to import virtual machines in the OVA format to Proxmox as well. Googling around reveals how to do that, but basically you create the virtual machine in Proxmox and just import the disk from the OVA archive. Another cool thing I did, I created an Active Directory environment because I wanted to learn to administer Active Directory, and you can't really do that unless you build your own. And it was a large exercise in Googling how to do things and then applying those instructions. And things you can do with an Active Directory. So I also created a Windows Deployment Services installation. So it's basically a network boot environment for Windows. So if I need a new Windows server or a Windows workstation, I can just create a new VM and send it to boot from network, and then it boots to installer. Another thing I was learning with my AD lab was creating GPOs or group policy objects. So that's the magic that makes your work laptop do things when you don't look at it. So basically, group policy objects are things in the Active Directory that configure computers in the domain. So if you end up configuring anything on your virtual Windowses, you can probably automate all or some of that to group policy objects. Another thing was installing and using intrusion detection systems. And this is actually the reason I started building my home lab anyway, because so when I was studying for the OSCP for a bit over 1 year ago, I had a great lot of fun owning all those boxes, but I had a nagging thought that how could I ever detect if somebody is doing these things to my box that I was doing at those ones? So now I'm kind of learning how exactly that works out with setting up my own intrusion detection system. So basically, there are like two kinds of IDSs. One is like network-based, which means that something is looking at traffic in the network and finding out if the traffic is malicious or not. So as I'm running pfSense on my router, so PF blocker blocks kind of traffic based on blacklists of which IPs or IP blocks are observed to produce malicious traffic. And the other one is Snort, which is kind of looking at traffic, like content of traffic itself, and finding out if things are okay or not. And another category of IDS is a host-based IDS, which means that there are agents on computers to be monitored, and they collect different things like logs and other data and send them to a centralized server. So I was experimenting with these things on the screen. So Waza is one of those alternatives. It comes with a lot of features, and it's presenting its data in Kibana. I don't know how it works, really, but I'm in the process of finding out. And that's it, basically. The talk was really short, and I didn't really go into much details, but I hope the things I presented will inspire you to find more about these things on your own.
Fantastic. Thanks so much, Osku. Really
You're
awesome.
welcome.
And how can people find you if they want to know more?
Uh, you can, I guess, DM me on Twitter. I'll check if my DMs are open, and I'm also hanging around with the Discord, the Many Hats Club Discord, and so my nick is Osku there. So please
All
ping me
right.
and tag me if you want to find more about these things, and I'd be really happy to help you guys.
Awesome. And thank you so much for participating in Isolation Con. Finland's #1 security researcher, from my perspective, because I only know one Finnish security researcher. And Troy
And
Hunt
who's
doesn't
that?
count because he's based in Norway. So thank you so much for joining us. And we're going to take a short break while we line up with B. Bo Hu. Yeah, we're going to check out what I guess this would be an Indian security researcher who's going to be joining us. So super exciting. We're going from the north to the south here on Isolation Con.